If you want to get that A or A star in maths, you need to learn your trig identities. My students did, and check out the results. I even had one student that scored the very best in the world, 600 out of 600, 598 in further maths out of 600. Pretty good, huh? 100% A to A star rate in multiple years. The problem is, if you Google trig identities, you might come up with bewildering pages that look like this, or like this, or this, or this. Who's going to bother to learn all of those trig formulae? Nobody, right? Here are the key ones you need to know. Let's see if you know them. Tan A, sine over cos. Cosec, 1 over sine. Sec, 1 over cos. Cot, 1 over tan. How can we remember this set? Remember, it's the third letter that gives you the clue, what it starts with. You see that? Can help you to remember it, right? What about your Pythagorean identities? Sine squared plus cos squared, I think most people know, that's 1. But do you know 1 plus tan squared? That's sec squared. 1 plus cot squared? That's cosec squared. And what about your double angle formulae? Do you know those? What about sine 2a? That's 2 sine a cos a. Now there are 3 identities for cos 2a. The first one is cos squared minus sine squared. You can remember that's a bit like sine squared plus cos squared, but it couldn't be a plus here, right? Because otherwise that would be 1. It's just a silly way of remembering this. It's got to be a minus. And you can remember it starts with cos because this starts with cos. Just silly ways we can remember them. We could replace in brackets sine squared with 1 minus cos squared. So then I'd have a minus 1, but I have a minus minus cos squared, which would be a plus cos squared. But I've already got a cos squared here, so that would be 2 cos squared minus 1. And similarly, I could replace my cos squared, using this identity, with 1 minus sine squared. So that would be 1 minus sine squared minus another sine squared. That's going to be 1 minus 2 sine squared. What about tan 2a? Okay, this one's a little less common, but still useful sometimes. Do you know it? It's 2 tan squared a over 1 minus tan squared a. Okay, let's test you. Quick fire. Sine squared plus cos squared? That's 1. 1 plus tan squared? Sec squared. 1 plus cot squared? Cosec squared. Sine 2x? That's 2 sine x cos x. Cos 2x, remember there are 3 identities. Remember the first one? Remember it starts with cos squared. Not cos squared plus sine squared, because that would be 1. It's cos squared minus sine squared. What was that second identity? It starts with 1 minus. It's 1 minus 2 sine squared x. And the last one? Yep, it's like the middle one, but kind of the other way around, but using also cos squared rather than sine squared. Some trickier ones here. 4 minus 4 cos squared 6x. That should remind you a little bit of this identity. If you factor out a 4, you'll end up with 4 lots of 1 minus cos squared. And 1 minus cos squared, you should know that's sine squared. So this is 4 sine squared of, be careful, not just x, 6x. What about cosec squared minus cot squared? Which does that remind you of? It's this one, right? Just rearranged. If we subtract cot squared from both sides, we end up with the answer 1. And what about this one? Which one does this remind you of? Ah, that's a bit like this one. Think about it for a moment. It's tan squared minus sec squared. All multiplied by 3. We've got a 3 in common. Tan squared minus sec squared would be minus 1. But we've multiplied everything by 3. So this is going to be minus 3. And what about this one? What does that remind you of? It's a bit like this one here, right? Just with the x replaced by x over 2. So if the x is replaced by x over 2, what would 2x be? That would be 2 lots of x over 2, which would just be sine of x. And the last one. What about this? What does that remind you of? Well, we've got a sine multiplied by a cos. Can you see? We've got that here. But we've got a bit of a problem. We're missing a 2. So it's only going to be half of this. Half of what? Think about what's playing the role of x. Playing the role of x here is 5x. So double that would be 10x. So we've got a half of sine 10x. If you didn't know all of those off by heart, bookmark this video and come back to it. Test yourself every day until you can do it fluently.